The first section of this chapter is about circles and circumference. So this is what your notes sheet should look like. And we're going to fill this out. And we want to know some precise definitions of circles and how to find the circumference of a circle. And using measurements, be able to calculate things. So first of all, I would like to introduce you to this circle. And so here's a circle, and this is circle C. The reason it's circle C is because the center of the circle is the C. And the definition of a circle is the set of all the points in a plane that happen to be the same exact distance from the center. So every point on this circle is exactly the same distance. That's why it doesn't bulge out. It's not an oval. It's a true circle. Then we need to put another point on the circle, and this point F is on the circle where C is the center. And the segment that connects the center to a point on a circle is called a radius. So the plural for cactus is cacti. The plural for radius is radii. So if I ask you to find the radius of a circle, you're going to list one of them. But if I ask you to find all the radii of the circle, you need to list them all. So segment CF is a radius of this circle. Then we can also have another type of segment in a circle, and this segment goes not from the center to the circle, but from the circle to the circle. And so segment AB is something called a chord. So a chord is a segment that has endpoints on the circle. It has a beginning and it has an end. It started at A and went to B, and once again it's a segment. The circle is named with 1 point. A radius is named with 2 points and a segment mark on top. No arrows, just a segment. And a chord is also named with 2 points. Capital letters with a segment mark on top. And finally, we can have a third type of segment in a circle, and this happens to be segment DE. Segment DE starts on the circle, it goes through the center, and it ends on the circle. So segment DE is called the diameter. And the diameter of a chord or of a circle is a chord that passes through the center. So segment DE is a diameter. So if I take that diameter and I lay it down below, how does it relate to segment CF, which was a radius? Hopefully you recognize that CF is not as large as DE. The radius is not as large as the diameter, so the radius is actually 1/2 of the diameter, or the diameter is 2 radii. So D equals 2R is one equation that we can use, or R equals 1/2 D, or R equals D divided by 2 is a second one. So if I give you a diameter and want you to find the radius, you're going to divide by 2. But if I give you a radius and want you to find the diameter, you're going to double it. So to circumference. When we want the circumference of a circle, this diagram has the word circumference surrounding the circle because the circumference is the perimeter of the circle. It's the distance around the circle. And when we're trying to calculate the circumference, hopefully we realize that if we take a circle that has a radius of 1 or a diameter of 2, it takes 6.28 to unwrap that circle around that number line. So 6.28 is the number 2 pi. So if we're unwrapping it, 2 times pi is the circumference of a circle. And so 2 pi r is going to be 2 times pi times the radius. The radius of this particular circle is 1, or pi times the diameter is another form of that equation. So if I give you a radius, you'll multiply it by 2 and times pi to find the circumference. If I give you a diameter, you're just going to multiply the diameter times pi to find the circumference, and we'll also work our way backwards. So, first example, let's name this circle. When we want to name the circle, we locate the radius, the center, and then we say the center is the name of the circle. You can write the word circle, or you can draw the symbol for circle, which is a dot, a circle with a dot in the middle. Keeps us from looking like a 0 or an O. So this is circle X. We use a capital letter. To identify a radius, we can start at X and go to any of the points on the circle. So XV is one of the radii that has been created for you. That's one. Well, are there others? Sure. X to T would be a second one. X to U would be a third. Once again, use your segment symbols on top. And Z to X would be another. And of course, we can switch the order of the points. VX, TX, UX, or XZ are all segments that are the same, or are radii of the circle. If we need a chord, now we need to go from a point on the circle to another point on the circle, and so RS is one of our chords. There's also another one, that would be ZT or TZ, because it goes from the circle to the circle. And we want to specifically name the diameter of the circle. Now we need the chord that goes through the center, and that is ZT or TZ. So all diameters are chords, but not every chord is a diameter. All right, on your notes sheet, look at example 2. If they tell us that the distance between T and U, there's no symbol on top, so the distance between T and U is 14 feet. If this whole distance is 14 feet, what would be the radius of Q? So if I want to find the radius, I will take the diameter and divide it by 2 and get 7. Extra example 2, what if I tell you that the distance between L and M is 11, and I want to know what is the diameter of circle L? Well, the diameter of circle L is segment JK, but I want to know what the length of that would be. So if J to L is 11, then L to K is 11, and 11 plus 11 is 22. On to example 3. If we have something called a traffic circle, then we're looking for, see if I can get a color that will show up here nicely. Let's try the orange. A traffic circle or a roundabout is a circle that will help you avoid getting a head-on collision. And so this particular roundabout has a place where a car enters the circle that's 18 meters from the center. So from the center to the car is 18 meters. And if the car drives all the way around the traffic circle, they want to know what is the distance the car traveled. Well, the perimeter of the circle, or the circumference of the circle, is equal to pi times the diameter, or 2 times pi times the radius. If the radius is 18, the diameter is 36, so pi times 36, or 36 pi, will be our answer in meters. Now is a good time to grab a calculator and find your pi button. And when you take 36 times pi on your calculator, I apologize, I don't have a scientific calculator to show you, we will get a decimal. So you want to use your pi button as opposed to the number 3.14 to get a more accurate representation. And so if we type 36 times pi in our calculator, we get 113.097, so about 113.1 meters. This is the exact answer and the 113.1 meters is a rounded version. So watch your directions to see if it says in terms of pi or as a decimal. All right, so example 4 says to find the diameter and radius of a circle to the nearest hundredth. Hundredth means 2 decimal places. And so the circumference of the circle is 77.8 centimeters. So circumference is given, and we need to find the diameter and the radius. So if the circumference is given, you can choose to use pi d for your formula, or you can choose to use 2 pi r. And the 77.8 is our circumference, and we need to figure out what the diameter is and what the radius is. So when we're trying to calculate the diameter, it's being multiplied by pi. The opposite inverse operation is to divide. Let's divide by pi. When we divide by pi, we will get a decimal, and that decimal is 24.764. So 24.76 is equal to our d. If you chose to use the 2 pi r formula to find the radius first, you have to remember that in order to get the radius by itself, we're having to divide by 2 and to divide by pi. So if you're not careful and you take 77.8 and you divide that by 2 pi, you're going to have a problem because your calculator is going to tell you, if you take 77.8 and divide it by 2 pi, it will say that it is 122.21 centimeters. Is it possible for your radius to be larger than your circumference? Of course not. So what happened was your calculator understands our order of operations, and it's dividing by 2 and then multiplying by pi. So this is going to be the wrong answer. To get the correct answer, you need to take your 77.8 and divide it by 2, hit equals, and then divide by pi so that you're dividing by both 2 and pi. Or 77.8 divided by 2 and pi in parentheses will get you the correct answer. So ask yourself if your answers are reasonable or not, or if you could be making a mistake. All right, and have an extra example 4 if you needed to see it, but it's simply a matter of taking the 94.2, that is the circumference, and dividing it by pi to get the diameter, or taking the 94.2, that is the circumference, and dividing it by not just 2, but also pi to get our radius. All right, and then I have a last example. We're trying to find the measures of the intersecting circles. So they're telling us in this example that the diameter of circle K is 12 units. Well, diameter, once again, went from the end to the end through the center, so the diameter is 12. So this whole distance from here to here is 12 units. Excuse me, I wrote it in the wrong spot. So let's get an eraser here. It was circle K, not circle J. Sorry, it's not erasing like it's supposed to. Okay, we want circle K to have a diameter of 12 units. So if the diameter of circle K is 12 units, then that means the radius of circle K has to be 6 units. And the diameter of circle J is 20 units, so if the diameter all the way across through the center of J is 20 units, then the radius of circle J has to be 10 units. So from here, J to E is 10 units. And then they told us that between J and D, J to D is 8 units. So this distance is 8. So from that, we can surmise that D to E has to be 2 units. 10 minus 8 is 2. And if D to K is 6 and D to E is 2, then the distance between E and K has to be 6 minus 2, which is equal to 4. So that's what we're talking about today. I have an extra example. We could use it as a check, but I think you've got enough to be able to work through your assignment. First 5 questions are similar to example 1, different picture, different points, so you'll need to name things appropriately. Example 2 is similar to the problems 6 through 11. 12 and 13 are like example 3. 14 through 16, use your notes for example 4. And finally, example 5 is 17 and 18. When you're looking at number 19, you know how to do these problems. We're trying to find the exact circumference in terms of pi of the circle. So in order to do that, we want to locate this D, calculate what D is, and don't let this circle throw you off. If I had a figure that looked like this, and this side was 8 centimeters, and this side was 6 centimeters, and I need to know what D is, and I see this little note here, ask yourself what you would do to find out what D is, and then use that D to calculate your circumference.